Now let us see what is switching characteristics. So switching characteristics before that is switching characteristics is nothing but diode is operating in the switching mode. Now let us entering into the topic. We will have some definitions. So we will have some definitions, then only we can understand the what is a switching characteristics. So what is first definition is a recovery time. So what is a recovery time? In some time when the applied input voltage to the diode is changed or reversed in opposite direction and it attains a desired value at a interval of time is called the recovery time. In simply we can call when you switch the mode, when the diode is changing from forward to reverse direction and the current value, it will take some time to reach the steady state value. You can call it as a recovery time. To understand the switching characteristics, we need some more definitions. What is forward recovery time, storage time, transition time, and reverse recovery time? So directly we will go to the diagram. We can easily understand what is forward recovery time and storage time one by one. So the first diagram shows the input voltage, that is the input voltage changing from forward to the reverse direction, my VF to the VR. Next, so due to the minority condition, minority carrier concentration, the value will be decreasing. So you just refer the second diagram, the from forward to reverse direction input voltage, my minority carriers reaches the almost minimum value. Now what happened to the current? So the current, it won't comes to the immediate desired value. It will take some time. That is due to the minority concentration, it will go to the minus minus VR by R. You just refer the third diagram and it will go to the minus V reverse current and it will store or it will remain at some time, that is from T1 to T2 the value becomes, the current value becomes constant. So that time is nothing but storage time. Now we will come back to the definition of storage time. During the time interval from T1 to T2 the injected minority carriers remained stored and this interval is called the storage time. Now what is a forward recovery time? The time needs the forward voltage or current to reach the desired value after switching diode from its reverse to the forward biased state. In simply we can call whenever the diode switching from reverse to the forward direction, the diode reaches the steady state value. You can call it as the time reaches the steady state value. Time taken to reach the steady state value is known as a forward recovery time. What is a storage time? After it reaches the reverse, that is a negative current, and it remains some time, some duration, and that duration is nothing but storage time, TS. What about a transition time? So the transition time, the time interval between T2 and instant T3 when the diode has recovered nominally is called the transition time TT. So if you look into this diagram, third diagram, that is after that the diode normally recover from the storage time to the steady state time, that is in a desired value. So this transition time, that is this time from T2 to T3 is nothing but your transition time. So when you look into this ideal response, refer the ideal response, that is in the dotted line shows the ideal response, whereas practically speaking you are having some storage time and transition time. Now very important definition is reverse recovery time. What is meant by reverse recovery time means by adding of your total duration of your storage time and transition time, that is from T1 to T3 reverse recovery time is occurred, is delivered. So that is a major drawback of the diode. So if you come over this drawback, that is to eliminate this reverse recovery time, we will have some steps. We have to take some steps. So what are the steps we will discuss. Before that, before that the diode, the figure B, the applied voltage VI is equal to VF for the time up to T1 is the direction to forward bias the diode. The resistance RL, here the resistance RL is a large, so that the drop across RL is large when compared to the drop across the diode. So the current I is equal to VF by RL, that is my forward current. Now if you so you got some idea. So what is forward recovery time? From reverse bias to the forward bias, diode takes the time to reach the steady state value is called the forward recovery time. What about reverse recovery time? Means that is time reaches the reverse recovery time, that is from adding of your storage time to the transition time is known as your reverse recovery time, TRR. So to eliminate the TRR, in order to minimize the effect of reverse current, the time period of the operating frequency should be minimum of approximately 10 times TRR. For example, if a diode TRR of 2 nanoseconds, its operating frequency is equal to F max equal to 1 by T, that is 1 by 10 into TRR, 1 by 10 into 2 into 10 power minus 9 nanoseconds, which is equal to 50 megahertz. So keep in mind, so if you have a operation, so your operating frequency should be 50 megahertz if the time, that is reverse recovery time, is equal to 2 nanoseconds. Now factors affecting the switching time. So the factors affecting, some of the factors affecting the switching time are diode capacitance. So already we have discussed what is diode. So in the diode we are having a depletion layer. So two materials are combined, P type and N type material. In the junction we are having a capacitance effect. That capacitance effect affect the switching time. That capacitance effect it leads to the switching time. And diode resistance, there is a dropping, more diode resistance means more number of switching times takes place. So and doping concentration, what is meant by doping means if you are adding impurities components, that time also it will affect the switching time. So based on the material we have used. And next depletion width, so if we are having a depletion with depletion region, we are having a one layer that is one negative potential is developed. So based on the negative potential also the switching time varies. Now one important concept, how to reduce, already we have discussed reverse recovery time. How to reduce this reverse recovery time? By shortening the length of the P region in the PN junction diode, adding a gold impurities into the junction diode by diffusion, by in the diffusion method adding a gold impurities. So the gold doping, also called the lifetime killer, increases the recombination, removes the stored minority carriers. This technique is used to produce diodes and other active devices for high speed applications.